Hello everybody, welcome back and I hope I'm audible right now. Let's talk about volumes today. After a long time, this was the thing that was remaining. So let's simply go through it and then I'm gonna be learning more things about, I'm gonna be learning more things on AWS. Not enough, come on here. Kubernetes of course. And as for right now, we are gonna be getting this particular section done within an hour. Hopefully it will be done. And we'll be doing it both ways. There are two ways actually to use volumes and I'm gonna be talking about both right here, and once this particular section is done then we are gonna be switching to the next topic. I hope I'm audible. Yeah, so without any further delay, let's simply get started. When it comes to volume, so first of all let's talk about the topics that we have covered so far. First of all, we have covered the clusters, nodes, pods, replica sets, deployment, services. We have gone through all these things, and even we have gone through the example of this. Of course, let me have a look if I missed something. Otherwise I'll just simply keep going on from here. So services are done, and apart from the services, downsides of services we have gone through it. By the way, when it comes to services, so there are three types of services. So node port, and the cluster IP and load balancer. And there is something called ingress that we learned. This is mainly used for exporting. So if we talk about the ingress over here, so this is the configuration of ingress. We have talked about this enough, so not gonna be talking about it right now, but yeah, we do have it. And right now the main focus is gonna be on the volumes. Ingress controller, we have gone through it. No need. Namespaces we have gone through, and then install Nginx controller, that's done already. Adding routing to the ingress controller, that's done too. And trying traffic ingress, okay, let's talk about it later. Secrets and config maps, we have already gone through exactly how they are used and all. So by the way, if you have any confusion in this, so when it comes to secrets, so you can just simply create a secret that will be stored first of all inside each ECD, and from there you can just simply get the secret for your any pod or container that is running. Already going for ahead from here. Config maps, we have already gone through the same way. The way secrets are like config maps, and they are gonna be saved on the ECD storage, default storage of cluster, and then mainly the default storage of control plane, and then this is how you can just simply get the values as well. So pretty simple stuff. I'm not gonna be uh, going quite deeper into that right now, because of course we have talked about all these things. And the same goes with the secret. Let's simply continue. Config map versus secrets, we have gone through this. Adding HTTP using cert manager, we will be learning about it later, not really a big problem right now. Volumes in Docker. So first of all, we definitely we have gone through volumes in Docker. It's pretty simple. Like when it comes to, let me close this of course, and let me go to projects, learning, and I'm gonna be creating volumes folder here, volumes, and let me open with the code. So this particular thing is done. We will be getting most of the things done here itself, and let's see how it's gonna be going on. ls. Alrighty, so coming back to this one, talking about the volumes. So there are two types of volumes, and before even that we have covered volumes in Docker. And if you know volumes in Docker, so mainly volumes are used for persistent storage and all, so that even if your container, suppose, let me keep it even simpler, otherwise it will not make any sense at all. So if you know volumes in Docker, you will be able to understand the volume stuff here itself, here as well. But if you don't know in Docker, then of course it's gonna be hard. So ultimately what is gonna happen here? Alrighty, so coming back to this one. So when it comes to Docker, so ultimately Docker is used for running the containers and all. So ultimately, this is suppose your local machine that you have here. This is the local machine. Inside this local machine, if there is a container running, suppose this is the container that's running inside the machine. So let me give it the color as well. So this is the container running inside this machine. So why do we need the volumes? So what happens actually inside your local machine? This is the local machine, of course, that can be anything. Suppose Linux that I have here, Ubuntu Linux. So let me just simply keep it here. This is the machine, this is the container. Inside my Linux I have many folders. So if I want that a folder name users probably, or my dir, this gets this particular folder that can actually be anywhere. So this gets mounted to this particular container, and inside this particular container you will have another folder. So suppose that folder's name is I mean, depending on the container you will have. Suppose we have a data.db. This is mainly for the MongoDB. So what happens here? Suppose, come on. Alright, I should be able to select this. Yeah, here. So suppose this is the MongoDB container. So MongoDB is running inside this particular container, and once Mongo database is running inside this particular container, so Mongo database will be storing the all the documents collections here inside DB data DB. And what will I do? I will mount this data DB to my local dir. So this is gonna be database, just like this. It is not that much hard to understand if you actually have a look over here. So what we are actually doing here? MongoDB is running inside the container, and MongoDB is actually storing the database related data inside data/db, and I'm just mounting it to this database. So what is gonna happen, that whatever data is stored over here, that will be available in this particular database folder on my local device as well. So this is the benefit of using volumes here. So ultimately what will happen, whenever I just simply stored some data in the MongoDB, it is stored here, as this particular database folder is mounted to this particular folder inside the container. So whatever data I have inside this, the same data will be present inside this particular database folder as well. So for some reason, if in future this MongoDB that have it dies, okay, for some reason it dies, it does not exist. So in that particular case, whenever you are going to be creating a new MongoDB, so it will get the data from this particular database folder. So it's pretty simple. If for some reason, suppose this particular container that you had, it got deleted, then you created a new particular new container, and that new container had this /db mounted to this. So whatever data is present over here, that will be present over here. That simply means the new MongoDB container will have the access of all the data that it had earlier. Okay, so it just simply goes on like this. So this is all about containers right now, exactly how it works with the Docker. Now let's talk about the what? I'm gonna be talking about the volumes in Kubernetes. So in Kubernetes we have a main master plane, control plane. So this is gonna be the control plane here, just like this. So I have my control plane. Apart from this particular control plane, I will have some workers here. So this is gonna be worker number 1. So similarly, I will have many workers. Suppose I have 3 workers over here. So ultimately, this is what actually happens inside a Kubernetes cluster. We have control plane, we have many workers inside this, and those workers, suppose what I want that I'm running inside these workers MongoDB. So ultimately, when you are normally using this stuff, you don't really need to worry about it. Suppose you are running backend over here, you don't really need to worry about the volumes. If you are using frontend over here, you don't really need to worry about the volumes. When you are using MongoDB, at that time, ultimately any database, not only MongoDB, when you are using some kind of database inside your Kubernetes cluster in a node, at that time you need to persist the data. Persisting the data in the sense that whatever data I stored in this particular DB, this is at the nothing but a node. So what if this particular pod that I have here, node that I have here, node will always be here. Hello, am I audible? Yeah, coming back to this. So what I was just simply saying that, suppose inside the Kubernetes cluster, this is the Kubernetes cluster that we have. Let me give it some color. This is the Kubernetes cluster that we have. And there will be data. Suppose I'm running MongoDB over here. So what will happen? What will happen here inside data.db, data/db, the MongoDB data will be stored. I'm going to do one thing. I'm gonna be mounting this particular folder to the external volume. So that's gonna be external persistent volume. So what will happen? Whatever data I have over here, the same data will be stored over here. So this is gonna be the volume or persistent volume, I can say. Persistent volume. So persistent volume. So ultimately somewhere on the cloud or somewhere maybe in your machine as well. Machine in the sense there can be your laptop. Suppose you made your laptop a server. So ultimately the store kind of volumes, the data will be stored here as well. So you have your DB running inside the Kubernetes cluster, and inside the DB, if that is a MongoDB, so this is where the data will be stored. This particular folder that you have over here, DB, it is actually mounted to a persistent volume out there. So what happens whenever you the data gets saved here, the same data gets saved here as well. In case sometime you lost your pod, so this you will have to recreate the pod, I mean database pod, and whenever that pod gets created, whenever the MongoDB runs again, it will be getting the data from this persistent volume, and this is the main use of using the volumes and all. So this is one of the uses. So when it comes to volumes in Docker, we already know that, and even we have gone through it, so we don't really need to worry about it at all. And let me see if there's anything. Volumes in Kubernetes. So in Kubernetes, a volume is a directory, possibly with some data in it. So volume is nothing but a directory. Suppose this is the one. So this can be inside a machine, or this can be inside a virtual machine. Suppose you created a virtual machine, and then over there you just simply save this. So it's okay. It just simply will keep going on. Ultimately, whenever you store some data in the DB, that gets stored in the volume as well. And whenever it crashes or something, so you will be getting the data from the volume back to the MongoDB. As simple as that. So in Kubernetes, a volume is a directory, possibly with some data in it, which is accessible to a container as part of its file system. So if this is the container running inside this MongoDB container, it will be just simply accessible to this. And Kubernetes supports a variety of volume types such as empty dir. We will talk about it, exactly what is the use of empty dir. And persistent volume claim, secret config map, and others. We have gone through secret, we have gone through config maps, so we don't need to worry about them. Two things we are going to be talking about here: empty dir and persistent volume. Alrighty, by the way, let's talk about the empty di first of all, exactly why they are used for and all. And after that, we are going to be going to the persistent volume. By the way, when it comes to empty dir, they are sort of ephemeral volumes. What are the ephemeral volumes? Ephemeral volumes in the sense temporary volumes. So when it comes to this empty dir here, not config maps, not even ingress, we are going to be talking about empty dir. This sort of belongs to ephemeral volume category. Now the question comes, what is the ephemeral? Ephemeral stands for temporary. That simply means the empty dir that I'm going to be creating, they are going to be temporary volumes. First of all, let's talk about why do we need empty dir. And let me show you this thing to you using a diagram that will make more sense. So here I'm going to be talking about empty dir. So suppose you have your Linux machine. This is my main Linux machine. Inside that Linux machine, I have Kubernetes cluster. Pretty simple. This is the Kubernetes cluster. This is my main Linux machine. So let me have Linux written over here. So this is the top one, is nothing but my Linux machine, and then I have my Kubernetes cluster. So Kubernetes cluster, this is the Kubernetes cluster I have. Okay, once I have this Kubernetes cluster, then what will happen? Inside the Kubernetes cluster, of course, I will have control plane. So gonna be control plane. This will be controlling everything. Apart from this control plane, I have some workers over here. Suppose this is suppose I have two workers here. So this is the worker number 1. Similarly, I will have one more. This is the worker number 2. So this is how I have two workers over here. What happens inside the workers? Suppose inside the worker I have a pod running. So inside the worker I have a pod. That pod is running a container. Okay, I can have one pod, I can have even many pods. So suppose this is the pod number 1 that I have, and similarly I have pod number 2 as well. So this is the pod number 2 I have. Okay, once I have these pods, so what I want I want the state to be shareable. State to be shareable in the sense, suppose I have something inside this particular pod, so I want that to be accessible inside pod 2. If I have something inside pod 2, so that should be accessible inside pod 1. So what is the way for that? The way is pretty simple. That create empty dir over here. So I'm gonna be creating empty dir. Okay, empty dir, or let's simply name it empty here, or just to be precise, E over here. So this is the empty dir that I have created. That's nothing inside this. This first pod will be connected to this one. The second pod will be connected to this one, just like this. So now whatever I have inside pod 1, I will be mounting it to this empty dir. Similarly, whatever I have inside pod 2, that will be mounted to this. This is gonna be kind of the volume that is created, and using this if I change something inside pod 1, that will be changed inside this particular empty dir, and hence that is change inside empty dir that will be making the changes here as well. So it's like things are gonna be connected using this empty dir, and that's the use of empty dir ephemeral volumes, empty dir. So this is the main thing. So what we are gonna be doing in action right now, we are gonna be creating two pods inside the worker, and once those two pods are created, then we are gonna be creating the empty dir. We will be suppose writing something inside pod 1, then that should be and I will try to read something from pod 2. So the same thing will be written here, the same thing will be read from here. So this is what we are gonna be trying, and we'll see if we write something over here, or if we make changes over here, are we getting those changes reflected here or not. So that's gonna be the main goal of the first step, and then we are gonna be going through the another things. Okay, so I hope it does make sense. And as for the code, we already have the code over here. So when it comes to the empty dir .ml file over here, it will have this code. I will be going through the whole code right now, but first of all let me just happening for some reason I'm gonna be turning on do not disturb option here. My internet keeps dropping, but okay, that doesn't really matter. I'm live or not, I mean hardly matters. So let's come back to this one and talk about this. So I have deployment over here, I have metadata, this is just the name. So shared volume in deployment, or I can say, yeah, shared volume deployment. That is actually a good name because the volume is actually being shared among two pods. When it comes to replicas, I have one replica. That simply means one replica will be there, and that replica will be responsible for creating a pod or two depending on the need already. And selector, when it comes to the selector, so on the basis of this particular selector it will be selecting. So the replica set that I have, that will be selecting the pods. And how will the pods be selected? Pods will be selected on the basis of this particular volume, so no need to worry about this. Let's talk about specification over here. It happens the way I'm thinking that it should happen or not. So ultimately there are gonna be two containers, and in container 1 I'm gonna be making some changes. Those changes should be reflected in the container number 2, and there's gonna be a pod, and this is how it's gonna be going on. So ultimately just a sec, there are gonna be two containers, and there's gonna be top level pod as well. So ultimately over here there's going to be a top level pod just like this. Let me make it this one, or probably this one. Why am I not able to send it backwards? It doesn't work. It goes directly. What is the shortcut for this? If I want to send it backwards, order, control, and this, it should be working. Changing things inside the container number 2 as well, and for that thing I'm gonna be using empty dir, and this is the use of the first volume. Okay, pretty simple. And inside this particular stuff, the deployment is already ready, and I'm just simply saying that there is something called busy box. What is this busy box responsible for doing? Busy box is it's kind of an image. By the way, you can just use any container. Ultimately you can run two backends, and whatever changes you make in the first one you should be getting in the second one, and all that will be working. We are using busy box over here. It is just an image that runs the process, and inside that I just have this particular command. What I wanna say, I'm just simply saying that it will be using bin /sh. That simply means it's gonna be using shell, and inside the shell, this is the command. C stands for the command. This is the command that should be running. And what am I doing inside the shell? This particular text hello from writer pod should be written inside data /hello.txt. So what will happen? A container will run. Great. Once the container runs, so inside data.txt, this particular text is going to be written inside that particular container. As simple as that, pretty simple. And once this is done, by the way, it should be written. We are even mounting the volume. So we have a top level volume over here. What is the volume? This is the shared data, or this is ultimately empty dir. Empty dir in the sense, this is what we are creating. So this empty dir that I was talking about earlier, so I'm creating it right here. So this is the empty dir that's getting created. Coming back to this one, once we have the empty dir that got created, we have two containers, container number 2. I'm gonna be mounting this empty dir to this container. That container is nothing but an array, so that can run more than one container. So this is the container number 1, this is the container number 2. Again, writer name can be anything. I have named it writer because here inside this I'm actually writing this stuff inside slash data slash hello. I will even show where it gets saved. And similarly, so mount path is slash data. That simply means this is the empty dir that I'm using. Okay, inside this empty dir, that's gonna be this particular when I'm actually mounting. So suppose this is the volume that I have created, name shared data. I can name it anything, and this is the empty dir that got created. That simply means this is just a volume that doesn't have anything. And here, while volume mounts, I'm mounting this particular volume. So this I have this empty dir in the container number 1. This is the writer. This is the writer container. The name is the writer. So from here, on the writer I have slash data dir that is mounted to this particular empty dir. Similarly, this is the reader. Over here I have slash data as well, and this is also mounted to empty dir. So I saved some value in the writer. So inside slash dir directory slash data directory, I saved suppose hello.txt file that got saved here. That simply means that got saved here as well, as this is also connected to this one. So whatever I have inside empty dir, that will be available here as well. That simply means all the changes made in writer will be available inside the reader, and I will be exactly showing you whether it actually got created or not. So for now, what will I be doing? If I actually want to check this, so let me start let me do two things here. Two things in the sense, first of all, I have to start a cluster on AWS, because at the end of the day I'm gonna be using I'm gonna be using Kubernetes cluster that is actually provided by AWS. Why I need to do it? Because I will be using something called persistent volume, and for using the persistent volume you need to have an account on AWS. Like ultimately, what will I do? What is gonna be the last goal that here? First of all, I'm doing it like this, so it's gonna be done locally as well. Like locally, you are gonna be creating containers inside the pod. There are gonna be two containers. You are creating empty dir. They are gonna be connected to empty dir. Pretty simple diagram. So what I'm gonna be adding here, that will be added here, and if that is added here, that's gonna be reflecting here as well. Pretty simple stuff can be done directly. But at last, what I want to create a persistent volume. I have this database MongoDB running over here. So this is suppose MongoDB running inside a container. And as MongoDB is running, it will be saving the data to data slash db. As the data is getting saved here, I want to create a persistent volume out there. In that out there is gonna be EC2 machine of, suppose for now, that's gonna be EC2 machine of AWS. So I'm gonna be creating a EC2 machine. Over there, I'm gonna be running a server. And what will that server do? Come on, yeah. Okay, that's fine. EC2 machine of AWS. So inside this AWS EC2 machine, I will run a server. What is that server will be called? That server will be called NFS server. So there is something called NFS server. So I'm gonna be running this server here on AWS EC2 machine. So what will that do? This NFS server will connect it to this slash data db. I mean, there are two ways to just simply create this external volume, external persistent volume. First one, you manually do it using is the automatic way. That's you just simply write the configuration that get automatically created. So we are gonna be focusing on both. First of all, we will go with the manual way, then we will go with the automatic way. And for that thing, I need a Kubernetes machine. So let me just start a Kubernetes machine so that it just simply gets started. And meanwhile, we will work with this particular stuff here. So how do we start a Kubernetes machine? Pretty simple stuff actually. For starting a Kubernetes machine, you need to make sure that you are configured. So you have to run a command called AWS configure, and over here you have to enter your ID and password. I mean ID and secret. How you will get the ID and secret? It's pretty easy. Go to AWS and go to what? You have to go to AWS. You have to go to IAM roles, and from IAM roles you can just simply create a user. Once you have the user, you will get your you can create the ID and secret. So from here, as I have this particular role over here, add the permission. For now I have added a normal one permission, administrator access, that will give me all the permissions. And apart from this particular thing, if you go to security credentials, from here I have created a key that is mainly for, what is the description, AWS S3 access. So this is the access key that I have created. It gives me access key ID and it gives me secret. Add it there. When you run AWS configure, you have to just simply add it here. And once you have added it, so whenever you will run EKSCTL create a cluster, and cluster, I wanna create a cluster. What is the name of the cluster? The file name is gonna be, well, I have to create a file as well, so let me do that too. lsvi eks cluster.ml. I'm gonna be creating this file, and inside this file I will have some configuration. What is that configuration? I already have it saved in my notes. Again, you can ask AI to write the configuration for you for creating a cluster on AWS. I have used for creating a cluster on AWS. Let's simply get rid of this. What it is saying that API version kind cluster config, you have to create a cluster. What is the name of the cluster? The name of the cluster is this. EKS cluster will be created on AWS. AP South 1, this is the region, this is the version. I don't really know whether this version is, I think this is the latest version of the EKS. So this is the version of the EKS cluster. So if you actually go to AWS, you will see the version as well. And auto mode config, these are the 3 extra things I'm adding. You can even remove them, that doesn't really matter. Gonna be not talking about these things much. They are just simply extra configuration that you have to add. And managed groups, I'm creating a group called my nodes. That node will be responsible for grouping the nodes. Instance is gonna be t3 small, that's gonna be one that I'm gonna be using. And desired capacity is 2, only 2 nodes I need. One is gonna be control plane, that will be handled by the AWS itself. And desired capacity 2 means I want 2 worker nodes over here. Minimum size 1, maximum size 3, depends, like minimum I should have 1, maximum I should have 3. That is it. So ultimately the whole configuration is done here. And if I just simply run EKSCTL create, and can I make it a bit bigger? Right. So EKS create cluster, I am going to create a cluster. What is the configuration? Forget about the configuration. What is the file name? The file name is EKS cluster.ml. If you run this, what it will do, it will start creating a cluster on AWS. Right now if you go to AWS, so if I go to my AWS account here, and if I search EKS Elastic Kubernetes Service, so a new cluster will be created here, or will start getting created. So right now I don't have any. Very soon I should have one here, because I have fired a request from this side. So it will just simply send a request to the AWS for creating a cluster, and AWS will be creating the cluster with the configuration that I have configured. So okay, this EKS cluster, the name was EKS cluster, that's the same being created. Version is 1.35, and it is just being created. It is created a few minutes ago, sorry, seconds ago and all. So ultimately after some time this is going to be created, but again this is not created yet, so we can't really work with this one. So let me do one thing. This particular process will be responsible for creating a cluster on AWS. Let it just simply process the .ml, and again I have the configuration for this too. Though configurations are really easy, but it's better to just simply nodes. You get directly workers. You don't need to worry about control plane, because AWS handles it from its own side, and here you get the control plane directly, because this is the local one, right? So what I'm gonna be doing kind create cluster. I'm gonna be creating a cluster using kind. And what is the configuration? Configuration is the local cluster. And what is the name of this? I think name should be like this, probably. So name is gonna be what? Name is gonna be local cluster, just like this. Simply run this. It is just simply saying that Docker is not running. So let me start the Docker, because when the cluster starts, ultimately it runs the containers. 3 containers are gonna be running for control plane and 2 worker nodes, and that is why I just got this error. Right now container is getting created. Cluster is getting created. And that's gonna be the local cluster. Inside this we are gonna be working on this stuff. Pretty simple. Alrighty. Wait for a while. And I hope, as for this network issue, I'm not gonna be facing it again and again. Alright, cluster has been created. Kind create cluster. That's not kind get clusters. So this is the local cluster that I have right now. Apart from this particular thing, there is something called context, like KRML. I should rather say shared deployment. So let's name it better. So move empty dir to shared deployment.ml. Let's name it this ls. So ultimately, this empty dir that I had earlier, that has been named as shared deployment. If I cat a shared deployment, well, cat shared deployment.ml. So ultimately it is doing the same thing, but it is saying that this is the deployment, blah blah, one replica is gonna be there, and these are the labels that are used. So replica set will be using these labels. At the end of the day, I'm running this busy box image. This just simply runs a process, and inside that, what am I doing? I'm gonna be saving a file. This simply runs a process. So ultimately this is just the image that keeps your container busy, as simple as that, as the name suggests. Hello from writer pod. This particular text will be saved inside slash data. This empty dir is mounted to what? Slash data. That simply means slash data inside the reader as well as the writer. So whatever you change inside slash, K stands for kubectl. Okay, so either write kubectl or write K. In my case, I'm writing K over here because I have aliases set. So write kubectl and apply. I'm gonna be applying what? I'm gonna be applying shared deployment.ml that I have. Let's simply apply this. This has been applied. So K get deployments. So this is the shared deployment volume that I have. This hasn't been, it is not running yet. It is like ready 0. That simply means it's gonna take some time to just simply start. Okay, now it has started. Now I will have a replica set as well. So K get rs replica sets. Either you say kubectl get rs, you will rs, you will be getting the same result. So kubectl means K only in my device, because I am referencing K to kubectl. You better go with kubectl. You will be getting the result. Otherwise set an alias. Okay, so this particular thing is done. K get pods. I'm gonna be getting the pods over here. This is the pod that is running 2 by 2. That simply means inside the pod there are 2 containers and both of them are running. So K get logs. K logs of this particular pod I want. So let's say writer out of the writer and reader. I'm getting the logs. There were 2 containers inside this writer container, reader container. It selected defaulted to writer. That simply means writer's logs I'm getting, but that is just a busy box image that doesn't do anything, that keeps it busy. So now I'm gonna be checking the log. Going into the describing the pod. So K describe pod, and once I describe the pod, I will be knowing those containers. So it has started. Great. Apart from this particular thing, if you actually have a look inside the containers over here, so inside the containers I have this writer container and the command and all, you are just simply getting everything. And similarly I have this reader container as well in the command. You have 2 containers running inside the pod, and that is it. Now the question comes, does it work as expected? Even I can get the volume as well. So K get empty dir. Well, how am I gonna be getting the value of the empty dir? K get, okay, I have the empty dir, but how am I supposed to get the empty dir? And I don't think I have saved it here. Yeah, I don't have saved it here. So slash how to get empty dir, how to get empty dir in Kubernetes and volume in Kubernetes. Let's see what is the command for getting it, because we created empty dir, right? So we have to just simply check that thing out too. Oh, right now it is just simply taking time. What's the reason behind it? Oh, network connectivity is really bad. Coming back to this one, how can we get that empty dir? That's fine. What is the command for getting it? This is how we can just simply mount the path as well. Not really big problem. We created the empty dir. That empty dir will be carried where? Once the pod is running, you can interact with the volume to verify it is working. Bin execute a pod bin ssh. ls data cache, where libqueue pods volumes kubernetes, inspect host location advanced on the worker node where the pod is running. The physical directory is located at slash where libqueue pods pod id volume kubernetes this. Ooh, too much. Is there any way to get the is there any way to see the list of empty dir volumes? Oh, let's see. So kubectl get a pod and json is that's crazy. K get pods, K describe pod, execute. Okay, we'll have to figure out the things on our own. Let's first of all do one thing. As per the configuration, what should happen usually here? Shared deployment. We have two containers running. Yes, they are running. We have created an empty dir that must be saved inside the pod only. So inside the pod there must be empty dir somewhere. So we have to find exactly where that is, and that's gonna be the next goal. So what I'm gonna be doing, I'm already describing it. So okay, when I described it, we didn't really get anything needed here. So what I'm gonna be doing, I'm going to go inside the container. So k get nodes. First of all, I hope local cluster is running. K get pods. This is the pod I have. K execute. I'm gonna be going inside the container. Inside the pod, and we'll be seeing everything. By the way, you can go inside the container, so you will have to specify the name as well of the container. So which container you want to go in? Well, that's bad. In that case, as for this empty dir, just a minute if I can see it here. So this is the shared volume that I have, namespace, default, local cluster, start, app. This is that we have, pod template, okay, annotations running, IP controller, container, and port, bin, sh, running, restart, mounts. So what is happening? Slash data is mounted to shared data. So and the same on the reader side as well. So on the reader side, reader command mounts slash data from shared dir. So this is gonna be shared data empty dir that we have. It is mounted over here. And lastly, we have volumes over here. This is what I wanted to look. So in volumes, what I have? In volumes, I have shared data. Type is the empty dir directory that shares pods lifetime. Medium, nothing. Size, unset. Cube API access, this got automatically created. So this is the main thing that I have over here. This was created automatically. Let's not worry about this. So this is the thing. So ultimately, I have a volume, shared volume, and both the containers, container reader as well as container writer, both of them are mounted to that particular empty dir. What will happen? Now I can go inside the containers. How will I go inside them? So containers are running inside the pod. So this is the pod name. So Control Shift V, and what is gonna be the container name? Container name is gonna be writer. I wanna go inside the writer. So where do I need to mention it? I think this is where it needs to be mentioned here. So which container? Probably here. Container is gonna be reader. That's right. By the way, k get nodes. If I run this right now, if you see, because the volume got created on AWS side, and because of that thing, it is giving me new nodes. So ultimately, get all the contexts. K config get contexts. So I have two contexts over here, context number this and context this and context this. What I want, first of all, let's change the names. They have such crazy names. So what I want to do, k config update context help. So I hope help. I think I have to just mention the names if I'm not wrong. So the same command, and over here when I'm actually update or rename, I think rename context, because the names are quite crazy. Let me write help here. So for renaming it, context name, new name, so ultimately I have to add the names over here. So kubectl config rename context name the current one, and new name. Okay, got it. So k config rename, what is the new name? I don't have the new name here. K get k config get contexts. These are the contexts I have. These are the names that they have by default, such big names. So I'm gonna say I wanna rename them. What is the current name? The current name is this. Copy, paste, and the new name should be EKS cluster, just this one. Rename this. Wildcard is in front of the local cluster. Right now if I try to get the nodes, okay, get nodes. So these are the local nodes that I'm getting. Okay, earlier I was getting the EKS nodes. Okay, once this is done, so I was trying to go inside the containers. Okay, get pods. This is the pod. I have to go inside this particular pod, but inside one of the containers, two containers are running. So okay, execute in the interactive mode. This is the name, and what is the container? Container is gonna be writer in this particular case, and SSH. Writer. Yeah, now. So I'm inside this. I have these many things, and inside this particular container there is something data. Okay, this is what I wrote, right? What I said initially in my here when I just simply create. So I said one thing, binsh. Of course, it's gonna be using shell. It will be using command, and this was the command. What was this command saying? Said that echo this particular string inside /data/hello.txt. So inside hello.txt, this string should be saved, and data should automatically be created. So this is the data that we have. Great, we have the data here. By the way, let's try to do the same thing here. Let's exit it for a while. If I say ls, I have these many files, lsa. So yeah, so lsa. Alright, so suppose if I just write l, I would get only this way. Okay, ls hi.txt, no such directory exists. That simply means, bro, this data should exist by default. And when we run busybox, data already exists there. This data directory, it already exists there in the busybox. As it already exists, so when we created the volume, we were able to mount to this particular /data because in busybox it already exists. So let me even ask the AI directly. This, when I run the image of busybox, does it already contain a directory called data? Let's see. Because we did not create the directory, it was already there. No, the default busybox image does not come with a pre-created data directory. What busybox actually contains? Busybox is very minimal. Linux, it typically includes bin, etc, this essential utilities, but the data is not included by default. What happens when you... What is the problem? This D that I had, this should be somewhere here. Okay, that's running right now. And docker process status, that started in docker process status for all. As expected, this busybox ran and then stopped for some reason. Great, let me run it directly. What is happening? docker run busybox. Why this stops? Docker process status. Let me ask this. Why does the busybox stops? Like it starts and then it stops when I run docker run busybox? Good question. This is very important concept in Docker. Why busybox starts and then immediately stops? Docker run busybox. The container starts, runs, and exits immediately. Regions. Container run only as long as their main process is running. The busybox image does not have a default long running process. It runs the default command, which typically does nothing. So process finishes instantly. Container stops immediately. Think of it like a container is not a virtual machine. It is just run this in okay. If the command finished, got it. So I have to give it some kind of command. So no command, nothing to keep it alive. Docker run interactive mode. And why it works? Shell is a long running process. Container stays alive until you exit. Docker and busybox sleep for 1000. Now container runs for 1000 milliseconds. Then it stops. Real time word. Busybox no default service exists. Nginx runs a web browser, keep running. Node.js runs. Okay, that's fine. Alright, what that is why we are saying here is sleep for 36. So 60 multiplied by 60 multiplied by 60 multiplied by 60. That simply means around for an hour or something it needs to run and then exit. So let me do one thing. Sleep for 3600. Docker process status. Now busybox is still running and it has slept for 3600 seconds. 3600 seconds or milliseconds? Ideally seconds, yeah. So what am I gonna be doing now? Docker execute inside execute interactive mode and sh ls. Do we have data? Well, if I have an empty dir volume, I created that and I mounted that to some directory. Okay, suppose I'm running busybox and I mounted a busybox to /data. So like I have empty dir, I mounted that empty dir to /data that is inside busybox. But by default busybox doesn't have /data, ultimately data directory. By default it doesn't have that. So what will happen when I run it? Will that mounted directory, ultimately the /data, will be created inside a busybox container or not? Yes, great question. This is how volumes behave in Kubernetes. Short answer, yes, /data will be created automatically inside the container. So even though busybox does not have /data by default, Kubernetes will create the mount path /data automatically, then mount to the empty dir volume. So whenever we say this, that bro, I am running a container busybox, the command is this will be running inside that. What does this command do? It runs automatically whenever this busybox runs, and it reads, and after reading it makes it sleep for 3600 milliseconds. So that is why it just keeps running. Volume, this is the empty dir that I have created, and I want to mount the volume. This is the volume that I want to mount. What I did, inside data I created hello.txt and I saved this particular text inside that. Let me see whether I have that or not. ls k get pods. This is the pod. K execute interactive mode. This is the pod. And what? I want to check the logs. So container should be writer, and well, I actually wanted to check the logs. There are no logs as such. Great. There is an error. Actually, forget about this. Should be writer. So there are no logs. okay, from the writer side, because of course I'm not getting anything. How about the reader? There is a log hello from writer pod. Why? Because inside writer I'm simply saving it inside slash data hello.txt. Inside reader I'm catting it. I'm just simply saying that the file inside slash data slash hello.txt, cat that, show the result of that, and as simple as that. The question is why this file exists over here? Simply because both these files are mounted to this empty dir, and because of this thing data is getting shared. Okay, so this is how it just simply goes on. And right now I can even make some changes here. Let me even do that. Let me go to the what gonna be interesting this time. What I want to do, I want to do one thing, that k execute interactive mode. What is the pod? This is the pod. What is the container? The container is gonna be the writer, and I have to SSH into the machine. Sorry, I have to just go inside the machine. ls. Now I have these things. If you actually have a look over here, I have data, cd data. What I have inside the data? I have hello.txt, cat hello.txt. I have hello from writer pod. So I'm inside the writer pod right now, of course. So ultimately I have these things inside this. Great. And what I want another one here, and I wanna copy the same command. Well, there are many. Oh, okay, never mind. Alrighty, these are the things I have inside the writer container, busy box, of course. So k get pods. I'm gonna be going inside the reader. So k execute interactive mode. This is the reader pod. Container is gonna be reader. I mean that is the pod. Inside that I have the reader container, and I have to SSH. I have to go inside the container ls. So right now, if I just simply clear it, similarly if I clear it too, okay, so they have been cleared. And if I say ls over here, so I have these things. If I say ls over here, I have these things inside data that is present here, and as that is present here, that is available here as well. Great. If I create something inside data, so like touch hi, I already have hello. Let me create hi.txt. As I created hi.txt over here, so now I have hello.txt, hi.txt, ls, hello.txt, hi.txt. So whatever I created here, that is available here as well. Whatever I create inside writer container, that is available inside reader container as well. Pretty simple. Inside reader, touch or vi by.txt. By and save ls cat by.txt. Ultimately I have this by, and over here ls I have by.txt over here, cat by.txt. It has the same value by. As simple as that. This does work. So we have gone through this particular thing. Pretty simple stuff. And the same thing we can do using the container as well. Like this has been done on local cluster. Let me do the same thing on what? Let me do the same thing on AWS cluster as well. So let's see how it's gonna be going on. Same thing. By the way, I will have to exit it from here. Okay, ls clear the terminal first of all. If I say k get nodes, I'm getting the nodes of the local cluster. K config get contexts. So I have EKS cluster, I have local cluster. I want to switch to EKS cluster because I want to do the same thing there. So k config use EKS use context EKS cluster. Switch the context. K instance for kubectl, of course. K config get contexts. Alrighty. Now earlier I had a local cluster running. Now I have EKS cluster running. If I try to get the nodes, k get nodes, it will take some time, but it will return me. So I have these two nodes running. They are from AP South 1 compute internal and all, that simply means they are the nodes. Okay, in the result, and there is nothing. So what I'm gonna be doing, ls I have this shared deployment.ml. I'm gonna be running this. So k apply f shared deployment, run this. So what will happen, it will create a pod, k get deployment. Now I have this deployment. Is this running? Ready? No. Wait for a can I do something for this network related issue? I can't. Usually I face it nowadays, even if I have the 5G mobile. Okay, doesn't really matter. Okay, by the way, this is running right now. Okay, get rs replica sets. Whenever I got the replica set, one desired capacity was one, even one is running, that's fine. Pods. Inside the pods, 2 containers are gonna be running. So it takes some time, and whenever I'm sending the request, this dies. Yeah. Let me fix this. By the way, this TLS handshake timeout. Let me fix this. I'm gonna be back after fixing this network issue. Hopefully it's gonna be fixed. So give me a moment, give me a minute, and I'm gonna be trying my level best to just simply fix the issue, and then I'll be back and continue from here in just a minute. Alrighty, here we are. Hopefully it's gonna be fine. Coming back to this, I just tried to fix this. Okay, I hope it's gonna be working fine. I'm not quite sure about this thing as well. If it works, that's great. If it doesn't work, using AWS is gonna be trickier here. Why? Because whenever I make a request to AWS, this OBS starts behaving crazily. That simply means if I make another request, as soon as I make a request, this gets back to, well, it doesn't behave like that right now. Okay, that's great. It is working fine at least right now. And if I keep facing the pod, inside this pod, the logs of a reader container. Let's see. Well, hello from writer pod. We are definitely getting it. That means it's working. We can even check this thing. How can we check this thing? K execute interactive mode, the same name. Container is gonna be writer first of all. Go inside the machine. So this particular thing is done. Same thing I'm gonna be doing on the other side. Let me copy it. Well, timeout again. Obvious thing. This should be reader here. Enter. Let's simply enter or not until unless I face the network issue, and that's high probability that I'm gonna be facing. Network. I'd better go, I mean, live either in the evening, maybe around at 8 or something, after the sun sets, or in the early morning. But in the early morning that's not really possible, so in the evening only it's gonna be possible. Okay, finally inside that. This network is crazy. Every time the request goes to AWS, it's crazy. I don't think it's gonna be working anymore. I'll have to end this right here. ls I data, ls I have hello.txt, cat hello.txt, and if I run this, I should be getting some result over here. Similarly, ls, nothing works. Alright everybody, I think I should be calling it right here, because if it just keeps going on like this, there's no use even doing this. ls cat hello.txt, hello from pod, hello from writer pod, we've got this. And if I make some changes here like vi hi.txt and hi from writer cat hi.txt, hello from writer, I should be getting it here as well. So ls cat hi.txt. Actually wanted to continue with this, but it is not really possible for me right now as per the network issue. So let's say all these things done in the, I may be recording it, let me just start recording as well, that would be even better. So recording would be a better option over here. So I have just simply started recording and I will premiere this if needed. Otherwise I'll just simply go on like this. As for this live, I'm just simply gonna be ending this. Unfortunately this is not working, so probably by the end of the day I will be just simply premiuming this recording. Otherwise I will not, it doesn't really matter. I will still continue from here on, but as I'm going with this AWS setup, it is not quite working because of the network issue. So let's simply call it here. I'm gonna be catching up soon. Until then, bye bye. As for me, I will continue. I will create everything whatever I